Morning, guys. We're just about to start class. Hey, Jaden, do this board too. Use the squirt and the paper towels. Thank you.
There's nothing down there, Jaden.
Let her be the captain of her own boat. Ace, you got your homework today? It's just gonna be, you're gonna like, oh. Yes or no?
Yes, you do. No.
Seriously?
Yes.
Dude. Well, I'll let you, you heard the expression, you're going to sow what you reap. You know what that means? So what does a farmer do? What does that literally mean? And plant seeds, right? So that's called sowing, right? Not like needle thread thing, right? But sowing. He sows the seeds. Reaping is what happens after it grows and he collects the crops. So the metaphor there is that you whatever it is you do in life, you know, you're going to get back what you put into it, that sort of thing. It is for you in your homework. You have a whole period. I'm gonna be on your case with student advisement from now on. You can hear this endlessly.
Just sit there and watch him do his homework because you just sit there doing it.
I'm trying to send a nice email home to your parents so that maybe cut you a little bit of slack, but you're cutting my legs off here. All right, grab the door, please. Find your seats. All right, please stand for the pledge. I pledge allegiance of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All right, find your seats, get out your homework. And then I need you guys to be quiet so we can do this efficiently. I need you guys to be quiet so we can do this efficiently. All right, show of hands, hot lunches today. Make sure that I look at you and I'm counting you. 1, 2, 3, 4. That's it, right? 4 people. I pointed to you. All right. All right. What were the instructions I gave you? Get out your homework and the part where we're going to be quiet. You're doing one of those well, the other one not so well. All right, time out. Time out. Let's go over the rules one more time. If I give the instructions, what should you do? Do it. You're in 7th grade. No more explanations. If I said quiet, it means quiet. Come on. You're still talking. One more, and we'll start talking about this, the D word, which is detention. Okay? So there's a second or two to get yourself under control, then there's annoying. You've reached the annoying stage. All right. Certainly, if you were 4th or 5th graders, we'd be having a better conversation. Hey, I don't know which class. No one has their names on calculators, but these were found. All right. This one is probably because it was found over here. Are you sure? Okay. It was found, I believe, in Ace's desk.
Yeah, I just want it.
All right. But do me a favor, you know, at your leisure, if you need a Sharpie, I think I have a Sharpie. Put your names on your calculators so when you do lose them, that there's a chance that it makes it back to you, and your parents don't have to buy you another, you know, $10, $20 calculator type thing. No, I'm not gonna, you know, the person that lost it, I believe it was second period, maybe it was third period, but we'll see. This was actually found in the parking lot.
Really?
Parking lot. This one was found in my class. So they're both the same calculators. Neither of them have any names. It has no names on it. The person that's in their bag and it falls out of their bag. Yeah. Well, you guys check on that and then get back with me. All right, you have your homework out, yes? All right. I had already heard from at least one person that they needed help on number. Let's take a look at number 34. All right, number 34. So as soon as we get up in those big numbers, you know, high 30s, that sort of thing, mid 30s, you know that they're supposed to be, by design, they're supposed to be a bit more challenging than number 2 or something like that. Empty board cleaners. My board looks excellent.
Tree clean the top.
Well, she tried.
I'm too short.
All right, 34 says on a number line, a number A, there's A, it's on a number line. You agree? Okay, the number A is between X and Y. Okay, so clearly X and Y are on the opposite sides, but which goes where? With just that statement, it is between X and Y, you're left to wonder, is X bigger than A or is it smaller than A? The next statement tells you the exact relationship. It says X is smaller than Y. X is less than Y. If X is smaller than Y, therefore X needs to go on the left, Y needs to go on the right, and we're already told that A is between X and Y. Therefore, it doesn't matter. I'll just put 2 tick marks. We're not told any more information than that. I don't know if those are correctly placed, meaning like, I don't know if X is 400 times smaller and Y is +1. We don't know that, so just make a pretty good estimate. And the estimate is, I just put a tick mark and I place it there. If we're not given any other further information, then we can't actually judge where the tick marks go. But we can say the order of the tick marks, X, A, Y.
I got it right.
All right, anyone else? That's pretty big boy, big girl math right there. That's not like, notice we dealt with no numbers there, just variables. Yes.
30.
Let's look at 30. Okay, it's one of those 2 that gives us issues. The 2 that give us issues are the problems dealing with
Money.
time and money. This one is money. The value in cents. So immediately when you hear cents, you're thinking pennies, right? I'm not converting dollars to cents. I'm in cents. Okay. The value in cents of D dimes. How many cents in a dime? So 10 times D is less than the value in cents of nickels. Well, that's kind of clear, right? How many pennies in a nickel? So if I have n nickels, I would take n and multiply it by 5, right? I'm going to put the 5 in front of the n. That's kind of how we do things. And I'm going to put the dimes. How many pennies in a dime? 10 times D. You tell me, what should I put there? Greater than or less than? I should put less than, right? There's fewer pennies in a nickel than there are in a dimes. There you go. That was number 30. Yes. Oh, wait. I didn't read that correctly. I'm wrong. No one caught me on it.
What?
I left off the fact that it says in number 30, it says the value of D dimes is less than, I mean, great, if you had 1 dime and 20 nickels, you'd have more pennies and nickels than you would in dimes. So you were told that there are fewer dimes than there are nickels, and that the total value of the pennies and the dimes is less than the value in pennies and nickels. All right. You could have gotten a free point there, but nobody caught me on that. But that's the answer. It's not that there are actually more pennies and nickels than dimes, but you're told in the problem. It's like having 1 dime and 20 nickels, right? Total number of cents, I have more pennies in the nickels than I do in the dimes. All right, let's grade the rest. Let's grade the rest. Here we go. Number 2. I'm going to have to show you hand and arm signals here. It is the greater than symbol. Number 4, it is also the greater than symbol. Number 6 is not. It is the less than symbol. Number 8, there are 2 symbols and they are both less than. That make sense?
Yeah, about 6.
It is also the less than symbol. I thought I called out 6. Maybe not. Okay. Number 10 is greater than. Number 12 is 2. I'm sorry. Number 12 is 1 greater than symbol. Number 14 is 2 less than symbols. Number 16, 12 is less than 22. Okay, that's literally what it says. This is hard to say. You know, I'm reading out the equation or the inequality, and that's exactly what it says for the problem. Number 18, 19 is greater than 9. All right, from left to right, 20 is 0, is less than 8, is less than 10. Yes? No, okay, good. 22, I will check 22 and 24 because I need to look at your number lines. So pick it up on 26. 6 is greater than T. 28, P is greater than Q. We just did 30 on the board. 10D is smaller than 5N, or 5N is greater than 10D, either one. 32, I'm going to read it from left to right. 6 is less than 2N is less than 8. Okay? And the last one, right? We already drew it on the number line. Therefore, X is smaller than A, and A is smaller than Y. Right? It's from left to right. Yes?
So if there were problems that we didn't get, would that be like?
Yeah, you just mark that through and then you put minus however many you missed on the top. Yes?
Sorry, not put the number line in there.
You didn't have to put the number line helps us understand the relationship. Okay? So if you didn't put a number line, that's perfectly fine. The inequality was the answer. Yeah.
If I accidentally marked one wrong, but it was wrong, should I
Just scratch through it, it'll be fine. The top is what I look at. I'm not saying that I don't look at your homework. I look at everyone's homework. So every day, for instance, when I grade his homework, I'm gonna look at it. It says -0. I typically memorize about 4 or 5 answers just to make sure you're grading it correctly. Flip it over. I look it over like, yep, I don't have a problem with Pierce on this homework. Maybe next homework I have a problem. Problem being like, wow, he missed 10 of them. That's a lot. So then what happens is, and if you've noticed during student advisement, sometimes I come up to you and I say, hey, what happened on that homework today? Or if you fail to turn in your homework,
What? Okay.
if you fail to turn in your homework, I come up to you and say, where's your homework? Remember me doing that yesterday to a few of you?
That was me.
That was 8.
Yes, it was you.
That was 8.
All right.
Nope.
Yes.
All right, who's my people?
Abby.
All right. Hey, yesterday someone said they were going to turn their homework. They didn't turn in their homework, so just make sure that you do it back. When this time comes around, once again, big girl rules, you got to turn in your homework. So make sure it winds up in the box when he comes around to collect the homework. That's your responsibility, yes? I will hunt you down, student advisement, if I think you've done your homework and I didn't get it. Everyone else, while all that's going on, look at the calendar. What's the next thing? Quiz. So let's talk about the quiz tomorrow. Quiet, please. What have we learned so far? This chapter. What have we learned so far? Well, certainly we did inequalities last night. That will be on the quiz. I will give you an easy one. 8 and 12. Give me the inequality set, and I'll give you a compound inequality, right? And then I might give you words, right? You got to write the inequality. What else have we learned in this chapter so far? That was am I on the right class? We're doing 2-4B today?
No.
We should be on 2-4. No, it's Tuesday, duh. I can't read my own calendar. Yeah, I'm staring at Wednesday, thinking Wednesday. I'm like, wait, when did I teach 2-4A? Oh, that's today, but we got quick. Yes, I'm good. Sorry for the confusion. That was 2-3 was talking about inequality. What was 2-1 and 2-2? What were on those?
Equalities.
I don't know. So what about equalities? Open your book. What did we learn in 2-1 and 2-2? What did we learn in 2-1 and 2-2? Somebody said equalities. What does that mean? 2-1 was writing an, not an equality,
Expression.
writing an expression. 2-2 was writing an equation. An equation is made up of how many expressions? 2, right? Separated by an equal sign. So if I give you a question on writing an equality, guess what I'm also asking you? If an equation is made up of 2 expressions and I ask you to write an equation, guess what I'm also asking you? To write an expression. So I don't need to test you or quiz you on 2-1, which is writing expressions. I just need to give you a quiz on writing equations. That will also evaluate, can you write an expression? In fact, I write 2 expressions. Thank you. Just put my L. I'm putting one on the empty box over. So the quiz will be on writing an equation from words, and then inequalities, what we did last night. That's what the quiz. Did we get the book thing under control? Whoever that was last night. I'm talking to Jaden. She knows what I'm talking about. You borrowed someone's book.
Yeah.
Okay. All right. So I love this class. I mean, like the math class. I love you too as well. Okay, whatever. But I love this class. It's a fun one for me, but I also have some issues with it. All right, who already knows that they are smarty pants? Okay, for you smarty pants, especially sometimes it seems like the boys, I'm going to teach you something. Put your hands down. I'm going to teach you something today while you're copying down your homework. I'm going to teach you something today that you're going to look at. You're probably looking at the sheet in front of you right now and saying, I already know how to do all of this. That is 100% false. None of you know how to do any of this. You're going to hear me say this at least 6, maybe 10 times today. I'm going to teach you something that you do not know how to do today, that when you look at the work, you're like, I can answer every one of these right now. You are correct. That's not what I'm teaching you. Today, I'm going to teach you a process. Today, you officially get your big boy, big girl math license. Right? You know, when you learn how to drive in 2 years, you get your learner's permit first. You get your license. Today, you're getting your learner's permit. Today, I'm going to teach you about algebra, how to do algebra. Okay? It is an introductory class. When you look at the sheet in front of you, all of you should be able to figure out every one of these without knowing how to do algebra. Okay? However, I don't want to teach you big boy, big girl algebra from the start. You'd be confused. So the way all math teachers teach you algebra is to start with the easiest problems ever. So when I teach this, yes, you already know the answer. You're not doing algebra. You're doing what's called, I'm just thinking it through. You will not be able to use that technique on the larger algebra problems, and I'll make that abundantly clear in the class. So for the smarty pants and the not so smarty pants, and the people that aren't paying any attention, I'm just going to warn you. If you don't solve these using algebra, it's wrong in the sense of not mathematical, but it's not what I'm teaching you. I struggle with 1 or 2 students every year that literally aren't listening to a word I'm saying right now. They look at this and they're like, I can do every one of these right now. Why do I need to use what you're teaching me? Because this is how we teach algebra, to do the more complicated ones when you can't just look at the problem and tell me the answer. All right, here we go. So the class is called Solving Equations and Inequalities. We're just going to do equations right now. We'll talk about inequalities on 2-4B. Actually, yeah, 2-4B. So it's big stuff. I mean, it's big stuff. Today's an algebra day. I'm going to teach you literally how to do algebra, right? You're going to do a lot of writing today before we do any solving of an equation. All right. It turns out you've actually done algebra since the 1st grade, maybe even kindergarten. Do you remember in 1st grade, 2nd grade, you got a problem that looked like this, all right? That's how it looked like in 1st grade. What's the answer?
1, 4.
You actually are doing algebra. You just weren't told that you're doing algebra. Like, what do you mean algebra? Just what number added to 3 is 4? Well, that's 1. Everyone said 1, and you are correct. I'm going to warn you. That's not the technique that I'm going to show you today. Because in algebra that you get introduced in 7th grade, hey, you're 7th graders, this is what the problem looks like. What's the difference?
It has variables.
Instead of being a blank line, they put a variable. The variable represents that blank. Like, okay, well, the answer doesn't change. It's still, okay? The reason why you know the answer 1 is because you're not doing algebra. You're just looking at it. Works great when it's an easy problem. Yes?
Yes.
Okay, works great. X is equal to 1. Okay, works great. Turns out that there are steps to get to the answer, right? Turns out there are steps, and they're called algebra steps, and I will teach you that today. When you do the algebra steps, you find out the answer to this one is. And so the problem that I wrestle with, and it's happening right now, I don't know which one of you it is, but I will figure it out. Right now, you immediately turn your brain off. You're like, I can do every one right now. Oh, you can? What's the answer? You got 5 seconds. 4, 3, 2, 1,
8.
done. The answer is not 8. This can be solved in 5 seconds. Do you know how to do it?
No.
Wait, it would be easy if we would know what X is.
That's the goal in algebra, to figure out what X is. I said you could do this in 5 seconds. Can anyone do it in 5 seconds? Okay. Therefore, when I teach you how to do this using algebra steps, you better pay attention. Because if this can theoretically be solved in 5 seconds, then I'm actually going to show you something today. Yes, we're only going to look at really easy ones because I don't want to teach you how to solve the complicated ones yet. I will, but not today or tomorrow or the rest of the week. Every one that we do this week will be like this, very simple, and that you can solve every single one. Do I have your attention?
Yes.
Okay. Every one of them that I show you can be solved just by looking at it today. But that's not what I'm teaching you. I'm teaching you the algebra steps in order to get to the answer. Anybody solved it yet?
No.
What's the answer?
5.
The answer is not 5. No one can solve this? Clearly, you need to be taught algebra. Okay. By the way, the answer is 4. All right. Okay. So the big but here is that what I'm trying to say is that I struggle every year. I don't want to teach you this complicated one. I want to teach you something that I don't need to teach you. Oh, by the way, let me show you the 7 steps it takes to get to the answer. I want to show you something simple. So the only problems I will give you today, tomorrow, the next day, and the next day are these simple problems. Okay? So this is where we're going to solve that one. But we're going to start off with the easy ones. Now we're going to do some writing before I show you anything. So box 1 and box 2. Box 1 has 3 boxes. Box 2 has 1 boxes. In algebra, we talk about the sides of an equation. Okay? If we think the equal sign is the middle of the equation. In fact, some teachers teach you to literally, I won't teach it yet until we get the more complicated ones, to draw a line straight through the equal sign. And what it does is it separates it into 2 halves. What? Want to take a guess what we call the 2 halves? What? Nope. Even easier than that. We're going to call this side, we literally will call that the left-hand side. We will abbreviate it LHS. Okay? We will call this side the right-hand side. We will abbreviate it RHS. So when I say look at the left side of the equation, obviously I'm talking about this. All right, hold your hands up like this. Which one says L?
This one.
That's left. Okay? All right, the other one is your right. All right, grab your pencils. Let's write this down. There are 3 key ideas in algebra. Just 3. 3 of them. They're ideas. They're not how you do algebra. They're ideas. The 3 key ideas. We will write this down for 3 straight days. These 3 key ideas. My belief is after 3 days you get it. The first key idea is this. Write this down. Given box to the very top box. Given an algebraic equation, that's an equation that has at least 1 variable. Given an algebraic equation, to find the solution, that means to solve it, you get the variable by itself. You get the variable by itself. You get the variable by itself. That's the key idea. When somebody says solve the equation, what do they mean? They mean get the variable by itself. What does that visually look like? Well, there's that big honking equation. We will do algebra, which I haven't described yet, until we get x on one side of the equation. It doesn't matter left side or right side, but it's all by its lonesome.
And then we're gonna jump.
Nope. What's on the other side where the question mark is the answer. I will do math. I will continue to do math until I find out what x is equal to. You are not done algebra until we say we isolate the variable. Big fancy math words for x is on one side of the equation all by itself. Is there anything right now on the left side with x? No. As we start, is there anything on the left side with x? What's on the left side right now with x? I got a 2 and I got a minus 10. I need to get rid of minus 10 and 2 to get x by itself. Okay? We're not going to do that one today. But this is key idea number 1. Get the variable by itself. Yes? The answer is, let me do this really quick one, is not. The answer is -4. All right. So what's there is your answer. Remember I said in math we're going to do 4 things. We're going to simplify, we're going to evaluate, we're going to solve, we're also going to factor, right? This is called solving. Okay, key idea number 2, second one down. In algebra, you are literally able to do the wrong thing if you so choose, as long as you do it to both sides of the equation. What I mean, do things. What I mean, add, subtract, multiply, and divide. You can do anything you want. But if you decide to do something, you must do it to both sides of the equation. You guys have seen in science the balance beam, or the balance, right? When you weigh something, it's called, right? You put some weight on one side, you try to get the balance or the balance level. That's this idea. An equation is a balanced equation, right? It means the value on the left is equal to the value on the right. If we add something to the left side, now the left side weighs too much. We got to add the same thing to the right side to balance it out. In algebra, we keep our equations balanced. By the way, what's the answer? Anybody?
28.
No, not even remotely close. The answer is 12. How am I doing this so quickly? Because I know algebra and you don't, but you will. All right, I am doing a process, and the process is quick, and it's not guess and check either. There's a process involved.
You forgot to put a period on
You could, sure. All right, so always imagine this balance, right? You decide to do something to one side, you have to do the other side to keep it balanced. If I decide to add 10 to the left side, what must I do to the right side? I also have to add 10, otherwise it's not balanced. You don't have to write this part, just the top part. Okay, we all right? All right, that's key idea number 2. One more. So, let's do a quick investigation, just to show you that you must keep things balanced. Hey, is this true?
Yeah.
All right, let's add something to both sides. Is it still true?
Yeah.
Yeah, well, 12 still equals 12, right, if I add. What about subtraction? If I subtract something from the same side or both sides, will it still stay balanced?
Yes.
Sure, 7 still equals 7. Not the same as what we started with, but it's still a balanced equation. What about multiplication and division?
Yes.
That works as well too. We multiply both sides by 3, we get,
30.
yeah, and 30 still equals 30. What, the big but, what happens, we don't do the same thing to both sides. So for instance, I add 2 to the left and 3 to the right, what happens? It becomes an inequality. We got a nonsensical statement that 12 equals 13. We did not put the same thing on both sides. So it's unbalanced, right? Clearly this thing does not equal symbol. Clearly it's not balanced. So you must do the same thing to both sides. So these are the first 2, yes?
Yes.
Last one. So we just decided on step number, or key idea number 1, that to solve something, we do things until the variable is by itself. Okay. Well, that means you've got stuff you need to get rid of. How do you get rid of things in algebra? we do something called the inverse. I'll explain that here. Just write it down for right now. Yes.
But do we have to write down everything or just the red?
The first day we're writing down everything. Tomorrow we'll write down what's in red. And I don't get rid of my. I don't change my slides. Stay with anything on this one. So inverse operations undo each other. They get rid of parts of the equation. Remember, our goal is to get x isolated, get it by itself. So I need to get rid of something. How do you get rid of something? You do the inverse. Inverse doesn't mean opposite. It means inverse. What's the inverse of tying your shoes?
Untying.
That's the idea of an inverse. It's something that undoes something. If I tied my shoe, I untie it. What's the inverse of untying your shoe?
Tying.
That's an inverse. It's not opposite. And the only reason we say that it's not opposite, because in math, opposite has a specific meaning, not this. In general, non-math speak, yeah, we probably would use the word opposite. But in math, we use the word opposite to represent, so we haven't talked about negative numbers, so I can't tell you what opposites mean yet. Gavin, you got this all written down? Trying? Okay. All right, so let's talk about inverses. All right. Hey, look on the left side. Is x by itself?
No.
What's over there?
2.
A 2 and a
Minus.
minus 10. Well, minus 10 really means we do what?
Subtract.
Subtract 10. So what's the inverse of subtraction? So guess what? I need to add to both sides to get rid of minus 10. So I'm going to add 10 to both sides. What's 10 minus 10? Poof, it went away. Now there's no longer a 10 on the left side. Yeah, but now there's a 24 on the right side. That's fine. I got rid of the minus 10. That's not the answer. That's almost, because now we got to get rid of the 2. Right. Yes. Well, we'll talk about that here in a second. So let's talk about there are more than 4 inverses. But we'll talk about the 4 inverses. Notice what times 2 is 24. That's why the answer was 12. That's why I could do that like that in my head. And you guys couldn't. Now you can. Right? You don't have to write all these down, but I just want you to realize that these are the inverses. The inverse of addition is, well, the inverse of subtraction is, the inverse of multiplication is, and the inverse of division is. Pretty self-explanatory, right? There are more. We'll talk about them next year, and then next year, and the next year. Okay, so this is what your box 1 looks like. Yes?
Yes.
All right. Now, none of these tell you like what to do. They're just key ideas. So now we're going to talk about the specific way to solve algebra problems. All right. Remember, our main goal in algebra is to get x by itself. I want x on one. It could be left or right side, depending on where it was to start. But on the other side of it is going to be the answer, the solution. Okay? We continue to work until x is isolated or by itself. On the other side is the answer. Okay? So write this down. These are the steps, box 2. Now let's do one, right? I call these the 3 questions and the 1 statement. You won't find this in the book. These are something I made up. To solve any algebra problem, you start off with asking yourself, is the variable by itself? If the answer is yes, guess what? It's already done. You don't need to do anything. But if it's not, well, then you say, well, what's attached to the variable? Remember when I asked you, hey, look on the left side, what's attached to it? You said 2 and minus 10, right? You got to get rid of one of them at a time. So then you ask yourself, well, how is that number attached to x? Is it attached by addition, subtraction, multiplication, or division? That 10 was attached by subtraction. So to get rid of that minus 10, we decided to do the inverse, which was add 10. Now we got rid of the 10. Now we can get rid of the 2. Hey, is the variable by itself? No. Something's attached to it. What's attached? The 2 is attached to the x. How is this attached? It's attached by multiplication. So what are we going to do to both sides? We're going to divide both sides by 2. That's how I figured out the answer was 12 in 5 seconds. Not all algebra problems can be solved in 5 seconds, but the ones that you're going to be doing today, tomorrow, the next day, and the next day can be solved in 5 seconds. using algebra, not I'm just looking at it using the kindergarten method. You're like, well, yeah, but the kindergarten method works. It sure does. For every one that we do today, tomorrow, the next day, the kindergarten method works, but it's not algebra. I need to teach you the algebra method because we're going on to the big, crazy, complicated ones. Kindergartners don't see that until 7th, 8th grade. You guys are in 7th grade. Are we good? All right. Well, if Gavin beats you, you got issues.
I haven't done it for last one.
Why did I say that? Sure. Is this a question about what we're about to do, or? All right. Here we go. So let's see one. Clearly, we all know the answer is, without doing any algebra, using the kindergarten method, we know the answer is 3. But using algebra, we better get 3. So here's how it works. Is the variable by itself? First off, where is the variable? Left or right side?
Left.
So I'm looking at the, remember, this is where we're going, right? Now you can do this one right now. Where's the variable? Left side. There it is, right there. On the left side, is there anything with the x?
Yes.
What?
+2.
There's a +2. So is the variable by itself? No. What's attached? A 2. How is the 2 attached to the x? By addition. What's the inverse of addition? So what do we want to subtract from both sides? Okay, we're not getting rid of the 5. The 5 isn't on the side with the variable. The 2 is. So we're going to get rid of the +2. How do you get rid of +2? One side or both sides? Now watch the way I write this. This is important too. Are you watching? Okay. This is how, because we're going to keep it balanced, you're going to write it. You're going to write -2 on the left side, -2 on the right side. I didn't put the -2 under the x. I'm not trying to get rid of the x. I'm trying to get rid of the +2. On the other side, well, obviously we're going to have a 5 minus 2. I'm going to draw a horizontal line. This is how you're going to do both addition and subtraction, not division multiplication. This is how you do addition and subtraction. You put what you're adding or subtracting underneath what you're adding or subtracting. And I'm subtracting 2 from both sides. Who's lost? Simple, right?
Yes.
It's really hard to get 7th graders to do this. Why? Because they already know the answer is 3, and they don't want to do it. They're like, this is stupid. I already know the answer is 3. You're making me do too much work. Why am I making you do this? Because we're going to be solving the complicated ones eventually. You got to learn how to do the steps. So you must tonight for homework. When I pick up your homework tomorrow, 0 if you don't do this. You must do this because I'm teaching you algebra. We're doing a little bit of pain right now so that when we get to the complicated ones, we'll be able to do them using algebra, and we can't look at it and guess the answer. Oh, by the way, what's 5 minus 2?
3.
What's 2 minus 2?
0.
What's x plus 0?
What? 3.
What's x plus 0?
3.
What's x plus 0? What's anything plus 0? Itself. So what's x plus 0? So on the left side now we have x. Is x by itself?
Yes.
And what I said in step 1 or box number 1 is what's on the other side is the answer. So what's the answer? 3. That's algebra. So why is it hard to get 7th graders to do this? Because you already know the answer was 3. Get over it. All right. Another one. Where's the variable? Left or right side? Okay, it's on the left side. What's attached to it? 6. How is the 6 attached to the x? How do you get rid of +6? Okay, we're going to subtract 6 from one side or both sides. How are we going to write that? Okay, go for it.
We're gonna do. So we're gonna have -6 and 6 and then
On
-6.
the left side, and then on the right side, we're also going to have a -6 with a horizontal bar, like we're doing addition and subtraction. Okay, 8 minus 6 is 6 minus 6 is, and what's x plus 0? So what's the answer?
X equals 2.
X equals 2. Once again, yes, nobody needs to actually do this to know that the answer was 2, but I'm teaching you algebra steps so that when we get to the more complicated ones, just so you know, These are called one-step equations. Why?
Because it takes one step.
There's only one number I need to get rid of, and it only takes one step to get to the answer. By the end of the year, you'll be doing three-step equations. The one that I showed you at the start was a three-step equation. And three-step equations are challenging to do in your head. Some people can do them. I don't encourage it, but some people can do a three-step equation in your head. Not one involving fractions. Those are a bit more challenging. All right, box number 3. Let's go. Let's get these knocked out. Oh, where's the variable now? It's on the right side. What's attached to it? How do we get rid of plus 3? Now, I'm hearing the same 4 people loud and proud, and that's good. If you're sitting there and you're like, a whole lot of stuff is going on, and he still hasn't convinced me, why in the world would I do this if I already know the answer is 18? I'm doing this because I'm teaching you algebra. So when we get to the more complicated ones, you'll know what to do. How do we get rid of plus 3? Subtract 3 from one side or both sides. Whatever you do to one side, you must do to the other side. Notice how I wrote this. I put the 3 under the 3 and the 3 under the 21. I drew a horizontal bar. Now let's do the subtraction. 21 minus 3 is? 3 minus 3 is? So we get x plus 0 equals 18. X plus 0 is? X. So therefore 18 equals x, or x equals 18, either way. Yes?
So I was doing what you did, but then so.
Are you on box 3?
Yeah, I'm on box
Okay.
3. I did what you did, but what is it if I cross it out?
Yeah, no, you're going to need to do it exactly. Plus the bar needs to go all the way over to the other side. All the way over to the other side. What?
My pen cap.
We'll find it and move on. Okay. Please do box 4. You have, I don't know, 60 seconds is all it should take you, now that you know what you're doing. We're not using the kindergarten method. We're using the algebra method, which is painful and slow. And it seems like it's a waste of time because you already know the answer. And I agree, on a one-step equation, it is definitely a waste of time. But we are eventually going to be doing 3-step equations this year. And we need to know how to do algebra. And I don't see anyone doing it incorrectly. Very good. Yes?
I have a question. So just subtraction is just the opposite, right?
It is. Except we don't say the word opposite, we say inverse. So other people are already jumping ahead. But yes, they are correct and they are figuring this out. Today, all we're doing is adding, subtracting. Tomorrow we will do division and multiplication. And then, let's see, tomorrow is Wednesday, and then Thursday, Friday, we do inequalities. We will see 2- and 3-step equations later. Bless you, bless you, bless you. All right, time is up. We'll start in the back. What's the answer? Go.
0.
Yeah, go for it. Say the answer loud and proud.
0.
Okay, when we say an answer to an algebra problem, you know 0 is technically reality is 0. We're going to say variable equals the number. Okay, so what's the answer? X equals 0. All right, because when you subtract 7 from both sides, you get 0. You're like, that doesn't say x equals 0. That says 0 equals x. Same thing. Okay. All right, next, bottom left. What'd you get? Yep. X equals 4. Very good. If we subtract 14 from both sides, make sure that horizontal bar goes all the way across. You'll see why when we talk about division, why it needs to go all the way across. All right, next, upper right.
X equals 9.
X equals 9. Very good. And the last one.
6x equals 6.
X equals 6 or 6 equals x. Either one. Are we okay?
Yes.
Moving on. All right. Does seem stupid, right? Like we're doing all this and man, I could have done all this without doing any of that algebra stuff. Remember, that's where we're going. That's what we will be solving eventually. All right. So here we go. So he kind of looked at the material ahead and he was like, wait, so to get rid of subtraction, all you do is? Yeah, it's the same idea except, you know, the inverse of subtraction. All right, where's the variable left or right side?
Left.
It's on the left side. It's over there. What's attached to it?
Minus 3.
Well, how do you get rid of subtract 3? What's the inverse of subtraction? Addition. So what are we going to add to both sides to get rid of minus 3? We're going to add 3 to both sides. Done exactly the same way, except now we got a plus instead of a minus. We okay? What's 21 plus 3? What's 3 minus 3? So we still get that x plus 0 equals the answer. And x plus 0 is? X plus 0 is?
24.
X plus 0 is x.
Why can't you just let us say
Remember, on the left side, we are simplifying, right? X plus 0, well, 0 added anything is itself. For those of you that want to argue that, wait a minute, it literally does say x plus 0 equals 24. I understand why you say 24. Right? I just wanted you to make sure you're simplifying just the left side. All right, one more. Where's the variable? Left side, what's attached to it? Minus 10. How do we get rid of minus 10? Yeah, if you minus 10 from both sides, you guys don't know about negative numbers yet. You get minus 20, right? So we want to do the inverse. The inverse of subtraction is addition. We're going to add 10 to both sides. 4 plus 10 is? Are you guys getting tired of writing x plus 0?
Yes.
All right, are you listening? You don't need to write it.
I keep been writing.
So what you can do, or what you must do, you're watching, you got to write this step. That is the step that tells me you know what you're doing. That's the plus 10 plus 10. But you can go immediately from here to the solution, which is x equals 14. That is allowed. This step right here is just to show you that 10 minus 10 is 0, but it seems like a wasted step in some sense. Yes?
If we have a test on this, would we lose points?
If you only put the answer as 14 and I ask you to solve it algebraically, yes, you will lose points.
I was going to say, if we don't do it that the algebra way, then you'll lose
I literally just said that. If you choose, because you're a smarty pants and you know that, well, 14 minus 10 is 4, that's great. I'm happy for you. If I asked you to do algebra, you need to show me algebra. So Ace, why am I doing this?
to show us how to do algebra.
No. Why am I doing this? No. Why am I doing this? What's the answer, Ace? I don't know.
Yes.
Right? You got to know algebra to solve that one. So yes, even though all of you could tell me, hopefully from the start, that the answer was 14, you got to learn algebra. How did I start this class? What was the speech I gave you? That there's always 1 or 2 kids, right, every class that can't get it into their skulls that this is what I'm really teaching you. I'm going to do it by using nice, friendly, easy, simple numbers, right? But if you don't know how to do this, oh, by the way, Ace, what's the first thing I'm going to do to both sides here?
We want to make them equal.
What is the first thing I'm going to do according to algebra? Okay, where's the variable, left or right side?
Left.
Okay, what's attached to it?
1/2
And?
minus and 7/8.
So how do you get rid of minus 7/8?
By adding.
You add 7/8 to both sides. Okay. See what I'm saying? If you learn the algebra steps, you can solve even weird, complicated, ugly ones. How is the half attached to x? Sure it is. How is the half attached to the x? We haven't taught you this yet, by the way. How is the half attached to x?
Multiplication.
Multiplication. How do you get rid of multiplication?
Division.
So we're going to divide both sides by half, and then you're done. Okay? That's algebra. But yes, every year, thank you for outing yourself there, Ace. I'll have kids that still can't understand why I'm making you do this. Yes? What's 10 minus 10? You're like, oh, wait, it says minus 10 plus 10. Okay, what's minus 10 plus 10? Still 0, right? All right. Where's the variable, left or right side? What's attached to it?
Minus 8.
How do you get rid of minus 8?
Add 8.
And a whole big long horizontal bar. 2 plus 8. So you can immediately jump to, okay, there's my present for you. The book will always write this step. I'm okay because after you do about 8 of these, you understand that right at this, it always says x plus 8 equals answer. So we're okay with jumping right to the answer. But that's the only thing I'm saying. I'm not saying you can go from start to finish, you got to write this. This tells me you know the algebra. Plus, it's going to force you to look at the numbers carefully rather than doing them in your head. Uh-oh, here's the only hard one. And this is not a, I shouldn't have shown this slide, but I'll show it to you anyway.
But it's on our paper.
It is, but it's because I also use this slide for course 2. And next year, you'll know negative numbers. Technically, that's -3.
Okay. Thank you.
Well, how do we get rid of -3?
Add.
You add 3 to both sides. So there you go. There's your bonus, and I usually throw this in there. At least the reason why I leave this in there, because I typically have more than one kid that makes a big complaint about why am I doing this, and then I show them this one and they don't know what to do. Like, wait a minute, it's attached by addition. Shouldn't we subtract? Well, if you subtract -3 from -3, you would not get 0.
You get minus
You get -6. Okay, so to get rid of a -3, you add 3. So no, you're not responsible for that one.
Or you could just multiply -3 by -3.
Maybe. All right, I did throw one in there just like that one. How are we going to get rid of the -6? All right, do these 4, please. Box 6, and then we're almost done. It's on the back. Yeah, combination, addition, subtraction. Say again? Yeah. 4 or 5 minutes. And I'm usually pretty good. You know, I've been doing this for a while. I can usually get my classes done right on time. Yeah. Well, which one?
On Mr. Chartier. Bottom.
This one? Well, this one? Well, what do you add to both sides? 5 plus 2 is not negative.
No, the one at the bottom down there is negative.
No. Well, okay, yeah, to start with, yes. This was for I usually have 1 or 2 kids that needs a challenge, so I throw that in there. Yeah. Just about. We got to do one more box and we're done. All right, you think you got all 4 answers?
No.
All right, upper left, go. Final answer. X equals 11, very good. You have 1 to both sides, do. Bottom one? And I haven't shown you this, you know, it's a bonus. So to get rid of a -6, you still add 6 to both sides. So you got x equals 10. Top one? Thank you. Voices being what's a ventriloquist, right? She's throwing her voice all the way up here. Good job. And the last one? Very good. You got this. Do you guys got this? All right. So what's the only way I can mess with you now?
Negative numbers.
Well, no, I'm not going to do that. I can combine addition, subtraction problems. So we did only addition, then we did only subtraction. Last box, flip it over. There are 4 problems. It's a combination of addition, subtraction. Make sure you do them correctly. Go, get them done. And I gave you larger numbers so that maybe forcing you to do a little bit of scratch work. Some of you. Others of you can do this in your head. Anybody need help? Which one? Where's the variable? Left or right side? What's attached to it? How do we get rid of 7? Both sides.
How does 7 minus something equal? How does 17 minus something equals 23?
Well, if this number is bigger than 23,
Oh wait, yeah, since it's flipped, it's just weird.
which is why the nice thing about algebra is I'm not saying you have to stop thinking, but you need to follow those steps. Anybody not help? No one? Oh, that's good. I threw no negative numbers. That's x minus 17. I see a couple people that are already done. A third of the class is already done. Scratch word. 3 plus 7. Put a 0, carry 1. 1 plus 2 plus another 1. There you go. All right, we did the back row. Let's do the front row. First one, upper left. What do you got?
X equals 3.
X equals 3. Very good. Oops. X equals 3 is good. I thought I had the answers. I don't. X equals 3 is correct. Bottom left. Go.
Bottom left is we add 6.
Okay, so you get X equals
88.
88 is correct. Upper right. Go.
Here.
Pierce. Come on.
Alright. X equals 0.
X does not equal 0. X equals 40. Very good. And Jaden, if she had done this one, subtract 12 from both sides. Jaden, 7 minus 2 is,
5.
and 2 minus 1 is,
1.
so therefore X equals,
15.
there you go. All right, tonight for homework, you have 20 problems. You tell me. How many did we just do?
14.
How many did we just do right here? We did 4. How long did it take you to do those 4? A minute. There's 20. So how long is your homework?
2 minutes.
5 minutes.
For you, 5 minutes. For others, maybe
86 minutes.
take how long it took you to do these 4.
Multiply it by
Multiply it by 5. That's how long your homework will be. All right. Here is your homework. Now, you will receive 0 points for your homework if, finish the sentence, if it's not done using algebra. If you just have an answer, that's just guessing at the answer. You must use algebra. So make sure you use the steps as you used in class. You guys did good. I was impressed.
Is class about to end? Is that where you need?
For everyone but you. No, yes. If I ever end early, I'll say something like, oh, you got 10 minutes left. Let's get started on homework. But you have about 10 seconds left.
Okay.
Ooh, how about that? Right on time. All right. E-learners, if you have any questions, send me an email. If not, I will see you in class tomorrow. Yes, what's up?
I was looking at this.
Where's the right side or left side we're working on?